Okay, welcome. This video will cover the introduction to using the double and half angle trigonometric formulas. The goals will be to evaluate expressions using double and half angle formulas and to use double and half angle formulas to solve real life problems. So I have gone ahead and pre-written out the double and half angle formulas, these first group being the double angle formulas. Worth noting here is that there are three variations of the cosine double angle formula depending on which information you are supplied with. For instance, if I was given the cosine and the sine of the angle, I would choose the first one. If I was given just the cosine, I would choose this second one. Or if I was given just the sine, I would use the third one. Also worth noting is in the half angle formulas, we have this plus or minus feature in front of the radical. We decide whether or not to use the positive or negative by whichever quadrant the angle u over 2 lies in. So if I had an angle that was if u over 2 was, say, 135 degrees, thus putting me in the second quadrant, the sine function would be the one that's positive. The s, meaning sine, would give me positive angle. And so everything else, cosine and tangent, I would choose to be negative. To remember real quickly, we have this little saying, all students take calculus, which will help us remember which functions are positive in which quadrant. All things are positive. Sine and its reciprocal, the cosecant, are positive. Tangent is positive and its reciprocal, cotangent. And cosine is positive and its reciprocal, secant, are positive in the fourth quadrant. Okay, so let's get into how to use these. If you haven't done so already, pause the video and write down those trigonometric double and half angle formulas so that you can use them. We're going to apply them now to this problem. Here I've got the question to find the exact value of tangent of pi over 12. To do this, I realize that pi over 12 is half of pi over 6. Okay? And if that confuses you, think, 1/2 times what gives me pi over 12? And then you can solve for this, multiply both sides by 2. That cancels that, times 2. And what that gives me then is that x is 2 pi over 12, which is pi over 6. So that's kind of the long way of doing it. You might be able to just do this in your head, that pi over 12 is half of pi over 6. If not, you can set this up and work it out every time. Alright, so that's what I'm going to do. Tangent of 1/2 of pi over 6. This pi over 6 is my u value from the formula. Okay, now it's not written as u over 2, but it's written as half of u. Okay, so now I can go ahead and crank this out. The tangent for the half angle formula, we're going to have positive or negative square root of 1 minus the cosine of u, pi over 6, over 1 plus cosine pi over 6. Minus on top, plus on bottom. It's worth noting that there is a variant of the tangent half angle formula that is popular. I'm not going to use it in this video, but I'm sure you can find it elsewhere. So then simplifying that a little bit, we get plus or minus the square root of 1 minus the cosine of pi over 6. Well, that's going to be square root of 3 over 2. Okay. And then 1 plus square root of 3 over 2. And then I'm going to choose which positive or negative to use. So I have to think about u over 2, or the half of u. That's pi over 12. Okay? Pi over 12, let's think about that. Pi over 12, well, here's pi over 6. We're familiar with that in the unit circle. Half of that, pi over 12, is still definitely in quadrant 1. So we know everything is positive in quadrant 1. So tangent is, whoops, sorry about that. Stylus went crazy. Tangent's also going to be positive, so positive. So this will be the positive square root of 1 minus root 3 over 2 over 1 plus root 3 over 2. Now, depending on your instructor's requirements, they may want you to simplify it from here. For the purposes of this video and for my FST class, I'm not going to push that. If you are looking at moving on in math, it's probably a good idea to practice simplifying this. But that mechanical endeavor can get a little overwhelming possibly for some folks. So I'm not going to focus on that in this video. But there we are. That is the tangent of pi over 12. Cool. The little quiz question for you. Pi over 12 is half of what angle? Just talked about that. That is half of pi over 6. Absolutely correct. Good. What is the cosine of pi over 12? Go ahead and quiz yourself on that. What is it? Pause the video and work it out. And coming back, you should have gotten that first one. All right, cool. So if you got that right, you are on the right track for this half angle stuff. All right, so now let's try a double angle problem. Evaluating trigonometric expressions, we're using the double angle. Here I say that the cosine of u is 5/13. Angle u is in the first quadrant. That's what it's saying here. Between 0 and pi over 2, that means u is in quadrant 1. Then find the sine of u over 2, and secondly, the sine of 2u. All right, cool. So because u over 2, all right, well, if I take half of something that's in quadrant 1, anything I draw that's in quadrant 1, there's an angle in quadrant 1, half of that is still going to be in quadrant 1. And everything is positive in quadrant 1, so sine of u over 2 is positive. Okay, cool. So sine of u over 2, we go back to our formulas that you had in the beginning. I'm going to choose the positive version because we just decided that it's going to be positive. Positive square root of 1 minus cosine u over 2. All right. Well, we were given what the cosine of u was in our original ingredients here. Okay, so I'm going to plug that in. So we get positive square root of 1 minus 5/13 over 2. Now this one isn't quite so bad to simplify, so let's do that. I've got positive square root of 1 minus 5/13. That's going to be 8/13 over 2. And so then that gives me the positive square root of 8/26. And, heck, let's go for it. Let's do a little bit more fun. Let's keep simplifying this. It's not too bad. Positive square root of 4/13, which would be positive square root of 4 over square root of 13. Almost home. Positive 2 over the square root of 13. Rationalize that denominator. We get a positive 2 square roots of 13 over 13. There it is. How much fun was that? Okay, and that would be the final answer, as simplified as anybody could ever want it. That's awesome. I could also, to help us in this next one, it isn't a apparent right away, but I'm going to end up needing to know what the sine of u is to do this. Okay, I know what the cosine of u is. To help us out with this next one, we're going to need to know what the sine of u is. So I can use a Pythagorean identity. Remember the Pythagorean identity, I'll just work that out on the bottom here, states that the sine squared of an angle plus the cosine squared of an angle is equal to 1. So we have the sine squared plus, let's see, cosine squared is going to be 25 over 169 equals 1. So we're going to get 12/13, and we're in quadrant 1, so it's going to be positive. So we're going to get sine u is a positive 12/13. That's just coming from simplifying this expression down here. Now sine 2u, all right. Well, we take a look at our formulas from the beginning of the lesson. Sine 2u is going to become 2 sine u times cosine u. And that's why we needed to know the sine u. It wasn't just for fun. It was to finish this formula out. So this gives me 2 times sine of u is 12/13. Cosine u is given to us in our original ingredients, 5/13. So 2 times 12 is 24. Times 5 is 120 over 169, and boom, there it is. All right, having fun. So I just applying the formula, and then I had to go out and find the missing information. Sine u, we used the Pythagorean identity to do that, and then it was plug and chug. Let's try this with a verification. All right. Now, it would seem with this verification that we would want to work on the right-hand side, because I generally like to go with the messier, bigger side. However, for this one, I'm going to use the left-hand side because we are going to use the angle sum and then the double angle formula on top of that to apply to this. So it has more lending itself to the topic at hand, our focus, so we're going to go to that side. So I'm starting with the left-hand side here. And so this is a strategy you'll want to make note of. Cosine 3x can be broken up into cosine 2x plus x. Apply the cosine angle sum formula. So if you're not familiar with that, you'll want to go look that up. That should be previously discussed material, hopefully. So that will become cosine 2x times cosine x minus sine 2x times sine x. All right. Now, cosine double angle formula here we've got, and a sine double angle formula. And the sine double angle formula, that one's easy. We have one choice to go from there. The cosine one, unfortunately, we've got 2 different versions of it. So that could end up being a real booger for us. We might not get this right the first time. We'll see what happens. Let's give it a shot. So I'm just going to go ahead and choose one of the formats for this. I'm going to choose, let's go with cosine squared theta minus sine squared theta, the first one I gave you. So that's just for the cosine 2x times cosine x minus sine 2x. Oh, we only have one formula for that, fortunately. That's 2 sine x cosine x. And then times sine x. Oh my gosh, I just made an error. I'm sorry. This x, I used theta. So try and keep that straight. I've been using theta so much recently that I wanted to use it again here. But I should be using x. So All right, let's try a little bit of algebra here. Cosine x multiplied inside here gives me cosine cubed x. Now that's looking promising. Minus, let's see, sine squared x times cosine x. Just distributing it in there. And then distributing this, I get minus 2 sine squared x times cosine x. How does that look? Well, it looks pretty good, except for this stuff here. That doesn't look so hot. So now I've got to decide how am I going to tweak it so that that kind of disappears. Oh, well, this, I've got one of these. Here, I've got two more of those. They go together. Hey, we got lucky. We chose the right one. I've got three of those I'm taking away altogether. Sometimes you just got to take a leap of faith with these. Unless you're super mathematically gifted, you're not going to see from start to finish right away. If you can, more power to you. But for most people, including myself, it takes a little leap of faith and just getting our hands dirty and trying something. And got a little nervous there in the beginning. It wasn't going to work out, but it did. We're okay. So I've shown how to go from the left-hand side to the right-hand side. All these conditional statements really should be biconditional statements. We could go either way with them, I suppose, but I like just writing it with conditional statements. All right, cool. For my students in FST, here is your assignment. For the rest of you, I hope you found this video helpful, and good luck, and go enjoy some math.